And they are highlighted. Now, highlighted in blue for a real life answer. This highlighting in yellow is there to remind you of what you actually do. Now, there's a reason I've done this. Remember back when we were talking about pi, and we always got those crazy decimals, and I told you your teacher is going to start wanting you to leave it as pi, right? Well, sooner or later, you're not going to give this crazy decimal. Because this decimal is way bigger than 2, isn't it? I just rounded it off. You're going to leave it written like this. And very soon, you're not even going to be having to deal with degrees. You're going to be dealing with something else that is not degrees. You're going to be dealing with what is called radians. Remember on your calculator, it would say deg or rad. You're going to be dealing with radians, because the answers are easier to work with. That will happen to you in the 12th grade. Okay? So that is why I have the actual thing written out here, what I actually am going to do. Everybody cool? All right. And then at the bottom, there's your answers. 35, 7, 10, 60, whatever that actual number is. I didn't do that one apparently. And 1.8. Can everybody do tangent trig? Even the people that had never seen it before? Was everybody able to do these 4 questions? Going once, going twice, going thrice. Don't worry, we're going to get a lot more practice on trig. All right. Please do me a favor and turn over to page, no, not 240. We are not done. Sorry, silly me. Turn to page 238. Angles in the real world. Because, of course, every triangle you practice with on this page is not in the real world, is it? It's a drawing on a piece of paper. It's flat. It's in front of you. Everyone agree? In the real world, triangles do not lie around on the ground, do they? They're up, they're down, they're side to side, they're all over the place. Okay? So there are 3 ways I like to make sure you're comfortable with angles in the real world, not just drawn on a piece of paper. Okay? And the first of those ways, oops, that's a highlighter, and I don't want to use a highlighter. The first of those ways is angles that go up and angles that go down. Most of you will already know this, but some of you won't, so we're going to explain it anyway. All right, so the first one is what we have is, we'll call them up and down. And they have proper names. We're going to talk about that in a minute. Here am I. Agreed? All right. When I look at something, like I'm looking at all of you right now, if we lock eyes, and you actually look in my eyes, it makes a straight line to your eye, yes? Everybody understands that, right? Your eyes can only really look in straight lines. Everybody cool? Like I know the light's behind me, but my eyes are looking right into Parm's soul. They're not really, they're just looking at his eyes, okay? I used to have a teacher that said when you look deep into someone else's eyes, you're not really looking into their eyes, you're looking at your own reflection because you're vain. That's really why we look into, people we like's eyes, so we can see ourselves. That guy was a little weird. He was a teacher I had. He was like, ooh, what's up with you, guy? But anyway, another story for another day. Your eyes can go in a straight line, yes? So, from my eye, just like Superman, laser beam. It's not really a laser beam, it's heat vision, but, Superman is one of those superheroes that whenever he needs a new power, somebody just gives it to him. Like, it kind of sucks, right? Like, oh, Superman needs see-through walls. Oh, yeah, he's got X-ray vision. Oh, Superman's trapped in a cage. Oh, yeah, he's got laser eyes. It's so lame. But anyway, that is what we call our line of sight. Okay? Easy peasy, wherever I'm looking. Now, let's pretend I am outside. and I hear up in the sky. What's up there? An airplane. And me, I'm not like you guys, right? I know that I don't have to be cool and keep looking around on the ground. When a plane flies over me, I look at the plane. Like all of you do too, because it's wicked cool. You're like, damn, I wish I was in that plane. If it's a big jet, ooh, where's that jet going? Ooh, Korean Airlines. I'd like to go to Korea. Or, ooh, there's a little plane up there. I wonder if those people are going to die and fly into the side of a mountain like every little plane does. Understand? I flew to Kelowna in a little plane once. We flew between the mountains. It was creepy. I don't want to do it again. But whatever. So, the plane is flying over me. Where do my eyes go? Exactly, Pavneet. They go up to the sky. Here is the plane. So my line of sight changes, doesn't it? It goes up to the plane. What did I create right here? An angle. We call that angle an angle of elevation. Why? Because my eyes go from flat, horizontal, up. It is also called an angle of inclination. Does everybody understand? It is the angle that lives between the horizontal and where you stop looking up. It has to live in here. Does everybody get it? Everybody says they get it, and then I give one question on it. Everyone's like, I don't get it. Does everybody understand this? I do not want to have to look 30 of you in the eyes like this and then stand up so you have to raise your eyes to keep looking in my eyes because that's creepy. Don't make me do it. Does everybody understand? Excellent. Now, plane flies away. Oh, it came back. Whatever. Plane flies away. I see something shiny on the ground. Just like all of you, what do? I look down at the ground. And down here is a shiny quarter. What's the smallest piece of change you will not pick up? Just out of curiosity. You're walking along the street, you see some money on the ground. What is the smallest amount of money that you would leave on the ground and not pick up? You would leave a quarter on the ground? You would just walk by a quarter? Really? Come on, what else you got? $1, did you say? Sky? If there was a loonie on the ground, you would walk by it? I didn't think so. What's your threshold? Would you pick up a dime? Be honest. We know Madeline won't. Money bags over here. A dime? Nickel? Would you pick up a nickel? Pennies don't exist anymore, so we can't do them. Wow. Quarter. See, when I was your age, a quarter was a video game. At the arcade, which don't even exist anymore. They should. Arcades were fun. Okay. So while I was walking, before I saw that quarter, where were my eyes? They were up. Plane's flown away, so they're back down onto my red line, yes? Then I see the quarter. Where do my eyes go? Down. Creating what? Another angle, yes? This angle, and I'm going to write it in blue because it is called, I'm going to erase line of sight. I'm going to move line of sight over to here. This line down here is the angle, and I'm writing it in blue because it is the angle of depression. Because you're sad. Or it is the angle of declination. Okay? Now, line of sight moves, doesn't it? Because when I look up at the plane, I'm creating a new line of sight, right? So really the angle is between the two lines of sight that I have. Everybody cool? Now the problem with this is when we flip it around. When the person's on the ground, it's easy. So now, up in the plane is another person. It's my wife. She's got blonde hair. she's flying the plane, which is another reason I don't want to be on it, because I've been with her in a car. I love you, honey. Where is she looking on the plane when she's driving it? Where should she be looking? When you're driving, where do you look? Forward. Well, not you guys. You're all looking at your phones. So my wife's eyes are looking straight forward, yes? That's her line of sight. She sees a super handsome fella on the ground. This guy right here. Where do her eyes go? Down to the super handsome fella, right? This angle right here, what is it? An angle of inclination or an angle of declination? This is the angle of depression, or whatever you want to call it. Okay? It is not over here, which is where a great many of you are going to put it on your first quiz and test. Now, what do you know about my wife's angle of depression and my angle of elevation? They are the same. Does everybody get it? Because my eyes go up that far, that section of 90. Hers come down that section of 90. Everybody cool with angle of depression and angle of elevation? All right. Excellent. On the second part of that page, divided in two. These are the other way we use angles in the real world. We use them when we are orienteering. What does that mean? Maps. Directions on a map. Okay? There's two ways we do this. Way one looks like this. What direction do we always say is up? Think of every map you've ever seen. What direction is up? North. Okay? Everybody knows that. It's not really up. We just decided that it was up. There is no up and down. So what's over here? What's to the right of north? East. Never eat soggy wieners. That's what I was taught. Northeast, southwest. Everybody understands, yeah? Okay. If I were to draw this, what did I just draw? And pretend I drew it perfectly. What did I just draw? A circle. Excellent. How many degrees are in a circle? 360. You've all played enough Shaun White snowboarding. You know what all the circles are. 360, 720, 1080, 1440, right? Okay. So, in a circle, there's 360 degrees. North is considered 0 degrees. So if I walk away at 0 degrees, I'm walking straight north. Everybody cool? So what am I walking if I walk away in an easterly direction? What do you think this would be? 90. Absolutely correct. So what would this one be? 180. And what would this one be? 270. Is everybody cool? All right. So if I tell you that I am walking on a heading of 77 degrees, where am I walking? Am I walking to the yellow dot, the orange dot, the purple dot, or the brown dot? The orange dot. Everyone agree? Okay. Because, as you can see, 0, 90, 77 lies in here, right? Now, here's where it gets tricky. We have been measuring our angles from the horizontal, haven't we? In directions, in orienteering with maps, we measure from 0. So, this is the 77. Does everybody understand? Now, if I want to do trig, I need a triangle, don't I? So I could have this triangle, with this being 77 and this being 90. Or I could have this triangle. What is this? If this is 77, what's this? 13. Does everybody understand why this is 13 if that's 77? Why is it? Yeah, the whole angle has to be what? 90, from 0 to 90. If that's 77 degrees of it, there's 13 left over. Is everybody cool? All right. Please do 3 things for me on this directional thing. I want you to draw a line at 115 degrees, a line at 205 degrees, and a line at 309 degrees. Draw those 3 lines approximately where you think they should be. I'm going to start my pen at 0. When I get to where you think 115 is, somebody stop me. Everybody ready? Are we happy? Do I care that it may or may not be exact? No, you're in the right section. I'm happy. Okay, that's the first thing I wanted you to do. Everybody cool? Now, how could you set this green line up so you could do trigonometry? Well, you would need to make one of these 2 triangles, yes? How big is this angle? Where the pink dot is? No. It's 115 all the way from 0. What is it right there? $25. Does everybody know why that is 25? The whole thing is 115. This part of it is 90, so that's 25. Everybody cool? What then is this part, if I need to do the triangle down here? 65. Everybody good? Okay, where's 205? You got 2 choices left. Is it the bottom one or the top one? Bottom one. 205. What is this in here? 25, which makes this what? 65 again. And 309 is going to go out here, yes? What's this here? This is a little bit trickier. 39. And what's this? 41. Can everybody do that side of the direction thing? Everybody understands? 0 to 360, we go clockwise, and we're trying to make fractions of 90 degrees so we can do trig. Everybody cool? Okay. There's another way we do this. Same thing, still north, east, south, west, but we write it differently. And the other way we write this, you get a direction, then you get a number, then you get another direction. This first direction is where you start. This is a degree, and this direction is the adjustment. So here is what I mean. If I told you I was going to walk north 30 east, that's how we write it. North is the direction I start in. So I would start walking straight that way. Does everyone agree? If I was just walking north. But I'm not walking north, am I? I'm walking 30 degrees away from north in the easterly direction. So, here I am, standing right here. What direction will I walk? Up and to the right on this thing. Agreed? So, I will walk this way. Oh no, I lost my leg! I lost my left leg. I'm all right now. I lost my left leg. I'm all right now. Nothing. I'm giving you your test right now. You guys are making me mad. So I've walked up here. Where is the 30? Is it in A or is it in B? Madeline says A. Madeline has answered every single question right. How many of you are willing to bet that she answered this one right? I'm not telling you if it's right or wrong. Do you want to change your mind, Madeline? Everyone's counting on you. You should see it. All 29 hands are up behind you. Every single one. Which is it? You're right, it's A. Because I adjusted 30 degrees from north. Everybody cool? So what does that make B? If A is 30, what does that make B? 60. All right? Now, I want you guys to give me south 27 west. Where would that green line be? Will it be in the blue, the green, the pink, or the yellow? Madeline says pink. Are we agreeing? All 29 of us? It is indeed in the pink section because I started south, but I didn't actually walk south, did I? I walked 27 degrees towards the west, which is over here. Here's the 27. Here is the 63. Does everybody understand how this works? Yeah? Okay. So if I said west 10 north, you would know where to put it? It would be right here. That'd be 10, that'd be 80. Are we all good with directions? Sweet! All right, it is 8:38. I want you on page 239 to do number 11, number 12, number 19, and number 20. Now, please notice I have supplied you with the answers. Right? Because this was a textbook page, and you always have the answers in the textbook. But you need to try it out to make sure you're getting it correct. All right? Notice, for number 14, you will need a drawing. Okay? That's what we're practicing now. Remember I told you that on a test, if you ever have to make a drawing, I will be coming around while you write it, and if it's correct, I'll put a big check mark by it. If it's not correct, you don't get that bonus mark, but I will give you the right drawing. Does everybody understand? It is mostly applicable to trig. Okay? Okay. You got 4 questions to do. It is 8:40, and you have the answers. You should not take that long to do it. Okay? It is cool what she's doing there, isn't it, Sky? I can do that with drumsticks, too. Because back in the day, heavy metal drummers would spin their drumsticks, but you're not really spinning them. It's just staying between the first 2 fingers. It looks way cooler. But if you do it fast, everyone thinks you're actually spinning around. Right, Kenzie? but it never leaves your first two fingers. But it's hard to do with the magic pen because there's a battery in the end of it, so it's too heavy. But I've been watching her too. It's been difficult. All right, everybody good? Go. I will call your attention back in about 12 minutes to go over these because kids have a lot of trouble with number 19 and number 20, even though they have the answers. Anybody need to talk about 11? Yeah, okay, so this one, that's the 20%, right? Because I go up 20 over 100. So 25 would be 25 over 100, 10 would be 10 over 100, and 15 would be 15 over 100. Is everybody cool with that? That's what percent means, right? So in a triangle, this is the angle of inclination always. So that's my theta, right? Because it's between the ground and up. And then 20 over 100, that is my opposite over adjacent, right? Since I'm looking for an angle, I must have to do shift tan of 20 over 100. But you can do that in your head. That's 0.2. So you do shift tan 0.2. What's it going to be here? Shift tan point what? 0.25. Or 25 divided by 100. Shift tan 0.1, shift tan 0.15. Everybody cool? Now, where do you see this? You've all driven in the mountains. Well, you haven't driven in the mountains, but you've been in the mountains, and you see the sign that says 8% truckers gear down, right? The yellow sign on the side of the road? Well, probably not because you're looking at your phones. But soon you will know what that means. That means that for every 100 feet you drive on the road, you're going to go down 8 feet in elevation. That's actually pretty steep. Okay? Anybody need to talk about 14, the bird watcher and the eagle? It's the first time I've asked you to draw the triangle. So we read the question. The bird watcher sights an eagle at the top of a 20-meter tree. Well, I'm not going to draw the tree, but there's the ground. There's the tree. How tall is the tree? 20 meters, so 20 goes there. The bird watcher is lying on the ground 50 meters away from the tree. Well, here's the bird watcher. Oh, except he's lying on the ground. 50 meters away. So what number goes down here? 50. I want to know how far I got to tip my camera up. Because if I'm lying on the ground, my camera's looking straight this way, isn't it? But I don't want to look this way. I want to look up at this eagle. So I got to bring my angle up. That's my theta. And then you all did page 237. Theta was unknown, but your opposite was 20 and your adjacent was 50. So since you don't know theta, it's shift tan of 20 over 50. Just like we did yesterday, except you had to draw your own triangle. And the answer is whatever it is, 22 degrees. Okay? This question is actually really hard until you think about it. Right? I'm going to zoom in because it makes it easier if it's zoomed in. So, you know this, don't want to use gray. You know this triangle size, yes? 7.5 by 11, right? You can see that, yeah? Okay. So what is this? Oops, I'll change color. What is this triangle side? What's that? How long is that pink line? 7.5. It's the same as this one, right? How long is that pink line? 11, because it's the same as that green line, right? So now I have this triangle, yes? How big is this peachy angle? Just the peachy side. No, just the peachy side. How long is that? I shouldn't be hearing silence here. All of you should be able to tell me what that angle is. 90, right? Okay, so this part of it is 90, so I just need this part, and I'll know the whole angle, won't I? How do I find this angle? Well, isn't it the same as this angle? That's what I need right there, right? So that is my theta. What's this that's opposite? 7.5. What's this that's adjacent? 11. And what do I do with that? I have to shift tan because I need that angle. When I get it, I'm going to find that it is 34.3. So 34 degrees. But that's only this part of it, isn't it? I need the whole thing. So it's 34 plus 90 to get 124 degrees. 146. That ain't right. No, because this is 90 and that's 34, so it's 124. That's right. That answer is not right. Unless I did that wrong. Opposite over adjacent. No, I did it right. And then down here, for safety reasons, a ladder is positioned. Now, this is another one of those questions that seems like not a real-life question. But it is. Because if you're working somewhere that needs a ladder and you place it wrong and you fall off it, whose fault is it? Yours. And if you do fall off a ladder and you bust yourself up and you can't work, do you get paid? No, not if you haven't set the ladder up properly. So, there's the ladder, yeah? It leans against a wall, yeah? Here's the ladder. Here's a wall. Now, does it matter how big the triangle is, or will this angle always be the same? Does it matter how big the triangle is, or will the angle always be the same? It's always going to be the same. So I can put any number I want in this drawing, can't I? Well, the distance between the base and the wall is no greater than 1/4 of the length of the ladder. So it would be smart if I use numbers that I could divide by 4, right? So if I say this ladder is 8, what would this be? 2. So now I can check. I just need to check the nearest degree, the greatest angle of inclination allowed for the ladder. Well, there's my angle, yes? But I don't have this side, do I? How do I find this side? Pythagoras. This side is the square root of 64 minus 4. It's the square root of 60, right? So now I have theta. My adjacent is 2. and my opposite is the square root of 60. So I have to do shift tan, opposite, square root of 60 over adjacent, 2. And I will get my answer. And I indeed have to the nearest degree 1/4. Yep. I have my right answer. The next page, which is page 240. Everybody draw a triangle at the top. Everybody put a big A there, and a big B there, and a big C there. This is 90 degrees. What should I write here for this side? It could be AC. What else could it be? CA, or it could be little b. We're going to use little b. What does that make this side? Little c. And what does that make this side? Little a. Right now, just to remind you, tell me the tan of big A. We just did 2 classes on tangent. Tangent is what? Opposite over adjacent. So what's opposite of big A? Little a, and what's adjacent? Little b. What is the tan of big B? Little b over little a. Good. What is, do you think, the tan of C? Can you do it? Yes or no? Well, what's opposite of little c? Sorry, the opposite of big C. Little c. What's adjacent? B is adjacent, but isn't A adjacent as well? Which one do you use? It doesn't matter because it doesn't exist. The tan of C, the tan of 90 degrees, is undefined because you can't do it. The opposite is the hypotenuse, and there's 2 adjacents. If you try it on your calculator, what happens? What happens if you try to do the tan of 90? Doesn't work. Math error, right? Because it doesn't exist. Everybody cool? All right. Now you will notice triangles have 3 sides. All of you, 90% of you know this already, but a couple of you don't. Triangles have 3 sides. Tangent deals with legs only. Right? Tangent doesn't touch the hypotenuse. But every triangle with a right angle has a hypotenuse, right? So we have to have something to deal with the hypotenuse, and that's what we do. Or we have that. One of them is the sine ratio. That on your calculator is the SIN button. The sine ratio compares the opposite to the hypotenuse. So it's just like tan, opposite adjacent, but now you're going to be able to use the hypotenuse. The cosine ratio, which is COS, compares the adjacent to the hypotenuse. which means it gives us this fake word, SOHCAHTOA, which doesn't mean anything, except to remind you it is sine, opposite, hypotenuse. That I should have done that in blue, because that's what I did sine in. No, I did sine in black. Sine, opposite, hypotenuse. Cos, adjacent, hypotenuse. And tan, opposite, and adjacent. Now, just to remind you, because this is all there is to trig. If you can remember these three things, and you don't even need to remember it, because I give it to you on your formula sheet, then you can do all trig until the end of high school. These three things. That's all there is to it. Everybody talks about how trig is so hard. Make a triangle, apply one of these three things to it. You have three choices. It is more difficult to choose the chips you want out of the vending machine than it is to do trigonometry, because you have to do one of three things, and the triangle tells you which one you have to do. So we are going to draw a triangle. We are going to label it the same way we just labeled the top one. You all, before the bell rings, are going to tell me the sine of A, the cos of A, and the tan of A. There's no numbers there, so you have to use letters. What is the sine of A? A over C, because it is opposite over hypotenuse. What is the cos of A? B over C, because it is adjacent over hypotenuse. And the tan of A we already know is A over B. Now, what is the sine of B? Cos of B and tan of B. We already know B is B over A. It reverses. So, what is the sine of B? Little b over c. And what is the cos of b? A over c. Please notice the patterns. The sine of one is the cos of the other, and the tangents are reciprocals. That is where we are going to stop, because the bell is going to ring in a moment. When you get back, we are going to practice some trig till the fire drills. Then you're going to come back. You're going to practice some more trig. I'm going to go show you the right answers. Then you're going to do a quiz on trig. Then you're going to have your break. Then you're going to have your first unit test. Aight? Aight.